Okay, so let's start, guys. So guys, last time we did these things, right? So we have done ticket number 1, that is layer 2 ticket, the switch troubleshooting. So any doubt in this ticket, guys? If you have any doubt, just tell me. First, we can clear all the doubts and then we can go to the next ticket. Anyone, any doubt? Okay, so in the first ticket, we did the switch troubleshooting. The second ticket was triple P. Okay, the fourth ticket we did, and finally we did the BGP. So these things we have done till this point. So today let's start with the 7th ticket.
Neeraj, your voice is breaking.
Sorry, the 6th ticket. So that is. Can you hear me now?
Yeah, it's better now.
Hello.
Yeah, it's better now.
Okay. So in this ticket, what we will do, we will discuss the BGP for IPv6. Okay. So what we have here, the mobile phone which is connected to mobile IPv6 network has lost access to remote server that is located in BGP. This is fix the problem. Okay. So finally, what we have to do, we have to fix the issue that is having this ping issue, and finally we have to do a ping to this address, and that should be successful. So let me show the diagram first. Okay, so guys, can you see the screen?
Yes.
So what we have here, let me show you the diagram. Okay, so we can see here Google, that is R33, right? Then we have R32, R22, R25, and this mobile user, right? So we'll be using these 5 devices in this ticket. So first of all, the network here, what we have in between R25 and this mobile user. So this mobile user will get an IP address, IPv6 address from R25. So this device will be having a DSP v6 pool. So this user will get an IP address, IPv6 address from this pool. Okay. Then in between R22 and 25, what we have IPv4 addresses. Okay. So we have to configure here IPv4. We have to use IPv4 address, and we have to configure IPv6 neighborship. Basically, what we have to do here, using IPv4 addresses, we have to activate IPv6 address family. Okay. So guys, any idea about this configuration, how we can do these things? We have to use IPv4 addresses, but we have to transport IPv6 data. Okay, I'll show you these things. Then in between 22 and 32, what we have IPv6 addresses, and we have to configure IPv6 neighborship. Okay. Then in between 33 and R32, what we have a pure IPv6 neighborship. So what we have to do here, we have to just troubleshoot in between 32 and 22, 22 and 25, and 25 and mobile users. Okay. So guys, any doubt till this point? Guys, can you see my diagram?
Yeah, Neeraj, I can see
Yeah,
your diagram.
I'm not sure if you're talking about some different diagram or the same, because I just can see the PPT. Some delay in, I mean, this network. Yeah,
Okay,
right now the
sorry.
diagram.
Okay,
Yes,
now it's up now. Yeah.
Can you see the diagram now?
Yes, yes.
Okay, everyone?
Yes,
It's visual now.
Visual now.
Okay, so basically let me show you again the diagram. Okay, and let me explain the diagram first again. So we have this diagram. Oh, sorry. Yes. Okay, so we have a mobile user, we have part 25. Okay, so in between these two devices, mobile user will get IP address, IPv6 address from R25. Okay, so I hope this is clear, right? Okay. Next, what we have, guys, please be mute. Okay, so what we have here, R22 and R25. So in between these two routers, what we are using here, we are using IPv4 addresses to activate IPv6 address family. Okay, so in this case, what we will do, we will be using IPv4 address and addresses. We will do a ping to IPv6 data. Okay, so that thing I'll show you how we can do that configuration in IPv6 BGP. Okay, then what we have, R22 and 32. So here what we have, IPv6 addresses and the neighborship will be on the IPv6 address family. Okay, so that will be the easy part. So now let's start the neighborship from, we will check the neighborship in between 32 and 22. Okay, so that will be the very first step. Then again we'll check the neighborship in between 22 and 25. Then we'll check the IP addresses on mobile user. So this will be the very first step because we have to check the connectivity. So whenever we troubleshoot any network, okay, so we have to check the connectivity. Do we have any connectivity there or not? So let's start from R22. Okay guys, any doubt in this diagram? So these 5 devices will be using in this ticket. Any doubt in this diagram? Amit, any doubt? Ben, any doubt?
As of now,
No,
it's okay.
good. Yeah.
Okay. Okay. So let me start with R22 first. Okay, so what we'll check here, we will check the neighborship first of all. Do we have a neighborship here or not? If not, then we will troubleshoot how we can bring the neighborship up. Okay. So the first command I will check here, show IP BGP all summary. So using this command, we can check all the neighborship here, right? So that is IPv4, VPN-v4, IPv6, IPv4 multicast, any kind of neighborship. So using this command, we can check all kind of neighborship. If I remove the summary, okay, so we can check the all received routes from all the neighborship. That is IPv4, IPv4 multicast, VPN-v4, IPv6. That doesn't matter. So enter. So right now, as I can see, we do not have any IPv6 interface level. Do we have any IP address on the interface or not? Okay. So in the background, you can see the interface that is E1 by 0. Okay. So show run interface E1 by 0. So yes, we have IPv6 address. Okay. Now I'll check the running configuration of BGP. So do we have that neighborship activated or not? Show run pipe section router BGP. So right now I will check the router BGP configuration. Okay. So right now, as I can see, we do not have any kind of neighborship here, any kind of IPv6 neighborship. Okay. So I'll just do one thing. I'll just check the address. So I can see here, this is the common subnet, and here we have .14 and here we have .13, right? So I'll just copy the address. We'll use .14 to activate the neighbor in address assembly IPv6. That's it. Okay, one more thing here. This is our ISP side, R32, the Google server. So these both are ISP and they are pre-configured. Okay, if the lab exam, once you attempt the lab exam, the ISP will be pre-configured in the troubleshoot session. Okay, you need to configure your edge devices. That's it. So I'll go here, we'll take the address first. interface E. This is a bit slow. Okay, so I can see here. So here we have 13. So I'll be using 14. Go in the configuration mode. Router BGP. So the AS number we are using 1, 2, 3, 4, 5. Okay. Now just going to the address family IPv6. Sorry, it's IPv4. IPv6. Okay. Neighbor. And copy this address. Use 14 here and put here remote AS. So the remote AS is that is 1001. Okay, so right now the neighborship should be come up, right? So we can check the again neighborship status. Do show IP BGP all summary. This is a bit slow. Just wait. Okay, so we can see here we have IPv6 unicast address family, and this neighbor is activated, and we are also getting a route. So we can see here state or slash prefix received. So right now, as I can see here 1, so it means what we have here, we have received a prefix 1, right? So if I see any state here, so we can see the state here. If the neighborship is up, then we can see the prefix received, how many prefix we have received from this neighbor. So let me check the prefix what we are getting here. Do show IP BGP all, that's it, without any summary keyword. Okay, so if I use summary, so that will show me the neighbor status. But right now, without summary only keyword, what we can see here, we can see the routes. So look here, we are getting this route, that's it, that is enough. Okay, so in between these two routers, R32 and R22, the neighborship is up, we are getting status in between 22 and 25. So guys, any doubt till this point? Any doubt in this, like BGP IPv6, what I have done, why I have done those configuration? So just ask.
I think it's good,
Okay.
but the connection just keeps breaking. Yeah.
Your voice is breaking.
Let me just explain here.
Neeraj, it's breaking intermittently, so like the continuity is not maintained.
This is breaking, right?
Yeah, yeah.
Oh, okay. Maybe like no worries. If you have any doubt, like you can ask again. I can repeat these things
Could you please repeat that the previous point?
Last time what I did,
Mhm.
the neighborship status in between like 22 and 32, right?
Right, right.
Okay, so what I have done here, so in address assembly IPv6, I was running a command directly this one. Basically what we do, we run this command globally in the router BGP configuration, but right now what I have done directly, I'm running this command in the address assembly IPv6. But what is the real manner? Let's say I'm doing a configuration, right? So what I need to do here, first of all, I have to go into the router BGP process, whatever process we have, and then we have to specify and then remote is. Okay. So this is the real way. Okay, and we activate that neighbor address and activate, right? So this is the real manner, like how we do the neighborship, right? How we configure the neighborship, but basically we what we can here and here. Okay, so using this command, like in this method, what you can do, I have done the configuration directly in the address assembly IPv6. I have, right?
And here's again, I think voice is breaking, or is it just me who is?
I think, yeah, the voice breaks. Yeah, it's not making it very consistent.
Yes, voice is continuously breaking.
Just give me 2 minutes. Let me check the wire. Okay, now guys, can you hear me? It's clear now.
Yes, yes, Neeraj.
Yeah, we can hear you. Yeah.
Okay, so now let's do the next part here. Okay, so in between R22 and 25, what we will be using IPv4 address. Okay, so what we have here, .17.18, right? So this router R22 will be using .17 common neighborship, right? And R26, R25 will be using this dot 18 to form the neighborship. So these two are IPv4 addresses. Okay, so using these IPv4 addresses, we have to configure IPv6 neighborship. Basically, what I need here, I need IPv6 neighborship using IPv4 addresses. Okay, so what we will do here, this will be very simple. I'll just go to the router process, router BGP 1 2 3 4 5. Okay, I'll just run a command neighbor, that neighbor address, that IPv4 address, and then I will define the remote AS. That's it. Now I'll go to the address assembly IPv6, not IPv4, and we'll be using this IPv neighbor, and we'll just say activate. That's it. So what will happen here using this command? We'll be using IPv4 addresses. That doesn't matter. That will be activated in the IPv6. It means this IPv4 will carry our IPv6. So any doubt in this configuration, in this concept?
So does it mean that we are advertising IPv4 6 address within IPv4? Is it like
Yes,
that?
correct. Using IPv4 addresses, we are trying to communicate the IPv6 data. We are trying to send the data of IPv6 using IPv4
Got it.
addresses over IPv4 addresses.
Got
Yep.
it.
And I think you can do the reverse way. You can reverse it also, right?
Sorry.
So I'm saying you can reverse it. Like for instance, if you want to do, if you want to put IPv4 into IPv6 address family, you can do the same thing, right?
Yeah. So now I'll show the same thing. Okay. So first of all, we have to verify these addresses are reachable or not. Okay, and then we'll move to BGP. Okay. The very first step, we have to check the connectivity. Do we have the connectivity there or not? And then we'll go to the configuration.
Not for me.
Okay, cool. So I'll just open R22. Okay, we'll check the configuration. We'll check the, first of all, the connectivity we'll check. So we have this address. Okay, so I'll do a ping to dot 18. Okay. Perfect. So it means that we have the connectivity. Right now, I will do the configuration for IP. Okay, can you see? Like we already have the command here. We just need to activate this neighbor in the address assembly IPv6. Okay, that's it. This. Okay, so this side we have done. Now I'll go to R25 and we'll do the same configuration. Okay. The name here, right? The configuration is here. We just need to activate the neighbor.
I believe same issue still persists. Is it for me only?
No, it's, I think it cut across everywhere. Yeah, this topic is a very important topic. So if connection is just
Just give me 2 minutes, okay?
okay.
Hello.
Yes, Neeraj.
Can
Yeah,
you?
Neeraj. Yeah. Yeah, we can hear you.
Okay, voice. Hello.
Yeah, Neeraj.
Yeah, Neeraj, we can hear you.
Okay, voice is clear, right?
Now clear.
Yeah.
Okay, perfect. Okay, so let me just activate this neighbor in the address assembly IPv6. Okay. Now address assembly IPv6. Just activate this neighbor again. Enter. Show IP BGP all summary.
Again, I think voice is breaking.
Yeah, I think I'm pretty sure he's having some issues on the back end.
I think he's on call.
Okay.
Guys, shall we start? Can you hear me now?
Yes, Neeraj.
Yes.
Okay, so it's like neighborship is up, right? So let me check like we are getting the route or not. Do show IP BGP all. Okay, so I can see the route, correct? But in this route, we have some issues. Can anyone figure out what is the issue here?
I believe it's valid, not waste, right?
Sorry?
It's not west route, right? I'm getting the route, but it's only valid route, not west
Okay.
route.
Perfect. So in what condition the route is not best?
It's not west.
So what we can check here, or what is the issue here, why this route is not best, that we have to figure out right now.
Yeah.
The next stop is reachable, I think.
Okay, right. So basically what I'm getting here, I'm getting this as a next stop, right? Correct. So right now what we have to do here, basically this is our IP, we are using here IPv4 addresses, right? And we are activating that neighbor in the address family IPv6. So what will happen here, by default, what they will do, the BGP will send IPv4 as a next stop. Okay, because in eBGP what we do always, what the neighbor will do, the neighbor will advertise the exit interface address as a next stop address. Correct? That is correct, right?
Right.
Okay, so right now what we need here, we need a IPv6 communication, so we need IPv6 as a next stop. Correct? If I will be having an IPv6 next stop, so I can send the IPv6 data. So what I'll do here, I'll just say to my routers R22 and 25, whenever we will send any route to R22 or 25, and if that is IPv6, just do one thing, use a new next stop address, use this IPv6 next stop address. Okay, still we are using IPv4 addresses, but we are transferring IPv6 prefix with IPv6 as a next stop. Okay, you get my
Neeraj,
point?
Does it mean that as we have made the neighborship of IPv4 addresses, within that we do need to mention, like we do need to make the neighborship of IPv6 addresses, right?
Right,
Got it.
because at last what we will do, we will send the real IPv6 data, right?
Yeah.
And end to end we are sending the data, so we need some IPv6 addresses as a next stop, otherwise the route will not be best, and we will not be able to send the data, right? So what I'll do here, I'll just configure some route maps, some policies here on both routers, and we'll put with the IPv6 neighbor, that IPv4 neighbor in address assembly IPv6, so that what will happen here, whenever these routers will advertise any route, any IPv6 route, that route will carry IPv6 as a next stop. And once the device will get IPv6 route with an IPv6 next stop, what they will do, the route will be best basically, right? So the next step, what we will do here, we'll configure some route map with IPv6 as a next stop, okay, and we'll put with the neighbor command, okay?
Okay.
So I hope this is clear, right?
Yeah.
Okay, cool. So I'll start from R22. So whenever R22 will send the route to R25, this interface address will be the IPv6 next stop address, correct? So I'll go to R22. We'll check the address, do show run interface as 4x0. So what we have here, this address, so let me just copy this address. We'll check the route map first. Do show run pipe section route map. Do we have any route map here or not? Because in T-shoot, basically we'll get everything, but those are not advertised, or those are not bind with neighbor command, or maybe they will be having some issues. Okay, so as I can see here, we have route map with the name IPv6 NH. This is next stop. Okay, so we are setting a next stop address here. So let me just verify that address is correct or not. Okay, so we have some issues here, right? So I'll just go to the route map. We'll modify this route map. Say no to this command. Okay, just put the command again with the correct address. Cool. And now I'll bind this route map with my neighbor. Okay, so router BGP 12345 address assembly IPv6, and the neighbor, let me check the neighbor. This is the neighbor. I have to put a route map, and the route map name is IPv6 NH. Enter. Okay, so we have to put in out direction. So whenever I will send the information out, I have to put this condition. Clear BGP IPv6. Cool. Okay. Now I'll go to R25. We'll do the same process. First, I'll check like, do we have any route map here or not? Show run pipe section route map. Okay, cool. I can see the next hop here. Do show run interface as 4x0. Okay, guys, we have to find the issue. Do we have any issue in this next hop, or this is correct? We can put this route map with the neighbor command.
The next was 17, I think.
Sorry. The next hop we have to choose always my own interface, right?
Yeah, this is correct.
Okay, so that is correct or not? Or do we need any modification here?
Yeah, this is correct.
Okay, anyone? So the answer is this is correct, right? All of you?
Yes, Neeraj.
Yes.
Okay, check the address again.
Oh, 17. This was 17. Making this one 18.
Okay, do you know what is the meaning of this double colon?
Two consecutive zeros or?
Correct. Consecutive zeros, right? So here I can see in this address we have here consecutive zeros in between these two addresses, right? But right now, as I can see here, what we have here, right? And what is the slash here? This is /64. It means this will be the network ID, correct? The rest of the part will belongs to host. But right now, look here, this is a bit different, right? That is correct.
Yes.
Right.
Right.
Yeah.
So basically,
Yeah.
I'll just do a change. I'll just change this double dot here, right? Because this double dot represent the consecutive zeros. So we cannot put here all zeros. We have to put those zeros here, right? Because this is the correct address and this is the wrong address. So again, we have to modify this route map. Okay. Say no to this command. Configure the address again. And this will be the address. Cool. Now I'll put this route map with a neighbor command, router BGP. Okay, so this has, let me check. Okay, 156.78 address family IPv6, and the neighbor. This is the neighbor. Route map. The route map name and the outer admission. Okay, so look here. I can see the route here, and that is best route, correct?
Yes.
Okay, so till this point, what we have done the neighborship in between these two devices again, like 22 and 25. We have configured a route map with the correct next hop. So whenever you configure any kind of neighborship, like you're using IPv4 addresses, you have to activate IPv6 neighborship. So you have to go with these steps. Okay. Okay. So now, let me go to the next step. The next step is this mobile user should get an IP address from R25. Okay, and then finally we have to do a ping. So till this point, till R25, we are getting everything. All the routes are best, right? So now this is the last step where we have to check the mobile user should get an IPv6 address from R25 via DHCP. Okay. So guys, any doubt till this point? Anyone, any doubt? Okay, so let me start this mobile user. IPv6 interface brief. Okay, so we are not getting any route here. So this is E0 by 0. So let me check the command. Show run interface E0 by 0. No IP address. IPv6 unicast routing. So that is a mandate part. So whenever we do any kind of different whenever VPN-v4 or multicast or IPv6, so we have to activate the routing. Okay, so by default on these Cisco routers, what will happen? The only IPv4 unicast routing will be enabled. So if you're working with IPv6 multicast, IPv4 multicast, so manually you have to activate those kind of configuration. Okay, now interface E0 by 0 IPv6 address auto config do show and let me check, no shutdown, do show IPv6 interface brief. Okay, look here, I'm getting the IPv6 address from DHCP. Perfect. Now let me check, do we have a route here or not? Do show IPv6 route. Okay, so basically what we should have here, we should have a default route here, right? So we can just put a default. Let me just say shutdown, no shutdown. Okay, so we are getting a default route and do show IPv6 interface brief. We do have a IPv6 address. Okay, so everything's fine here till this point. We are getting IPv6 address here. We have a default route here pointing towards R25, and R25 is getting some routes, IPv6 route, and that has a valid IPv6 next hop. 22 also is having both neighborship, right? So finally, I'll just do a ping from this mobile user and we'll check the real output. Okay, so the ping should go to this address. So let me just copy this address, go to the mobile user, ping. They should be successful. Okay, so this is not successful. Again, we have to do some other troubleshooting. Okay, so I'll just do a trace route. Okay, and you have to figure out where we can do the solution, like where we can put the solution. Okay, so let me do a trace route to this address. So the first hop, that is fine, everything is fine till this point. Now we are getting star star star. So now we will get this star. Okay, now can you figure out the real issue on which device we have to do the troubleshooting, or what is the issue in this configuration? So guys, before starting this troubleshooting, right, so you should know how ping works, trace route works, what are the features in trace route, right? What is the meaning of this star? So sometimes we get H, sometimes we get A, right? So what is the meaning of these things that we have to know? Okay, so reason behind, I can see this star here, right? So if I can see the star, so I should know the reason, in what condition we get the star and what we have to do at that time, right? So anyone, any idea what we can do here?
We can log into the router where this address is configured, and we will see further routes towards the destination on that.
Okay, so let me show the diagram. Just guide me what we can do here. Okay, so okay, so we have this diagram here, right? The next hop is R25. So yes, from that device, I'm getting proper reply, right? And then we are getting star star star. So I should open R22 or 25.
25
25.
and do the same trace from there. Yeah.
Sorry. Come again. What
R25. We are supposed to go to R25, and
okay.
from there we will again ping or trace to the destination.
Okay, so let me do a ping to destination. So this is the destination. Okay. From here again, we cannot do a ping, right?
For this, like, don't we get our query for IPv6 addresses?
In IPv6, basically we
ARP is
use a
also
different mechanism. In ARP, we use in the case of IPv4. Okay. In the case of IPv6, we use other kind of protocol, that is NDP, right? So that's not an issue here. Okay, let me explain you one process. Let's say we have R1. I'll take a normal example and you have to answer the real ticket. Okay, we have R3 and then we have R4. Okay, so the addresses we are using, we will suppose here this will be having 1.1.1.1. Okay, so let me note down. Number is 12.2. Okay, on this interface it will be 23.2. This will be 23.3 and this will be 34.3. This is 34.4 and R4 is having a loopback address that is 4444. Okay, so we are doing a trace from R1. Even R1 is having a loopback address 1.1.1.1. Okay, so we do have some connectivity issues, so I'm doing a trace. Okay, and in the trace route we are doing a trace to address 4.4.4.4 and we are using a source address that is 1.1.1.1.1. Okay, just tell me one thing, if I'll not use any source here. Okay, so by default what source it will take?
the interface IP.
Sorry?
The interface IP.
Interface IP address, perfect. The exit interface
The
IP.
R1's exit interface IP.
Right, perfect. So it will take R1 exit interface address as a source address, but right now let me use source 1.1.1.1. Okay, so I'm doing this trace. So this is the first case. Okay, and the first case, what we are getting here, we are getting a reply from 12.2 and those 3 timers we are getting here. Okay, no worries. And then again we are getting 23.2 and then those 3 timers we are getting here and then we are getting star star star. So now how we can identify here, till this point if we are getting reply, a proper reply from 12.2 and we are not getting anything from this neighbor, it means the source address, the destination address is reachable, everything's fine till this point. So who is this device? That is R2. Perfect, no problem. So till this point everything's fine, the device knows the destination and the source also, how
R2.
to give reply to source and how to reach destination. That is fine.
Yes.
Okay,
Yes, Neeraj.
Even R3 knows it.
now
And then we are supposed to check it.
correct, R3. So this is the IP address of R3. Again, I'm getting a proper reply from R3. It means the source and destination address is reachable. It means R3 know how to reach source and how to reach destination. Perfect. But I'm not getting reply this one, right? So it means what happens here, the upstream router, okay, that don't know how to give reply to the source. It means who is the upstream router? That is R4, correct? So it means this next hop router, this R4 router don't know how to give reply to 1.1.1.1. So whenever you get a trace route, you get output in the trace route like this. Okay, it means everything is fine. Till this point, the upstream router don't know how to reach source address. Okay, this is clear?
Yes.
Okay, in the second case, I'll do the same trace route. Okay, I'm getting a reply from 12.2. Those 3 timers I'm getting. Okay, and I'm getting a reply from 23.2 and those 3 timers, and then again I'm getting another reply from 23.2, that is H. So any idea What will be the issue here in this condition?
Means the packet is not going from R2 to R1. Buffer
Host not reachable.
Okay, no.
Host not reachable, right?
Oh, sorry, this is not 2, this is 3, sorry. Okay, this is 3. So what could be the issue here? How we can figure out like this is the issue and this we have to resolve?
Which means
Anyone, any idea?
H means actually host not reachable.
Host not reachable. Okay, so on which device we can say like this device, from using this device the host is not reachable? And what is the host, your source or destination?
the destination R4.
R334.
From which device?
From R3, R4 is not reachable.
Okay, cool, perfect. So basically what happens here, what is happening here, again from this device I'm getting reply, so source address and destination address, everything is fine till this point. It means till R2 everything is fine. Okay, but I can see I'm getting 2 reply from R3, right? So this is fine. It means source is reachable from this device. It means R3 knows how to give reply to source. Okay, we have a reverse route, no problem. But I'm saying that I don't know how to reach destination. It means in this condition what I will do, I'll check the connection in between 3 and 4. Maybe R4 is not giving me the destination, or I'm not able to reach the destination due to any ACL, due to any other reason, right? So at that time I will check the issue on R3, why I'm not getting the real destination address in my routing table. Okay, so what is the issue here? The destination address issue. Okay, the third case, same trace route I'm doing here. The source address is 1.1.1.1.1 and I'm getting proper reply, but here I'm getting a kind of A. Okay, now can anyone tell me like step by step, the first hop, the second hop, the third hop? Anyone?
It is reachable till R3, but from R3 to R4, we again have an issue.
Okay, so what is the issue? Any idea? So what is the meaning of this A? In the star, okay, cool, that source is not reachable.
So
H, destination is not reachable. What is the meaning of this A?
so the A is like there's an access list that is preventing the packet from going. So it's being denied by an access list.
Yes, exactly.
Okay, that is perfect. On which device we have to check? On R4, R3, R2, where we have to check this ACL?
R4.
R4. Anyone? Any other idea? Okay, no problem. So till this point, the source and destination both are reachable, no worries. Again here, source and destination both are reachable, but I'm getting here A. It means what happens here? R3 is giving me reply. I do have some ACL that is denying my traffic. Okay, so in this condition, we have to check the ACL on the same router R3. I'm getting reply from R3, so we have to check on R3. Okay, so here also we have to check R3. Here we have to check why R3 is not receiving. Okay, why R3 is not able to reach the source address. Okay, this is clear. This we have to check in between R3 and R4. Maybe R4 is not sending me any update, or maybe I'm not able to receive the update. And here we have to check the ACL and we have to permit the specific route. Okay, so I hope this is clear, right?
Yep.
Now
I have a doubt here.
Mhm.
This list basically works for source address, right? It is based, it's like access list source based. Like, will it consider
Okay,
destination IP address also? Like,
ACL,
or is it while returning the traffic?
yeah, basically what happens here whenever R3
It's
is
just the
getting a
access
packet,
list.
that is denying the packet. So right now we don't know that is due to source or destination, because in ACL we can match the source, we can match the destination also, right? So if I'm getting AAA, then we have to go to the interface, have to check the ACL, what is the real statement, and have to modify the statement. Okay. Because we have other methods also, like sometimes we match the source address. If I'll talk about the update, we can match the source and destination both. Yeah. Okay, so in this output, we were getting this one. Okay, so now just tell me what solution we can apply on which device.
So here I think we have to see like router 25. What if the we have reverse route to the mobile or not?
Come again, what you're saying?
Like here we have to see on the router 25 if we have the reverse route. To this mobile or not.
Okay.
I mean, if we can able to ping the IP which the mobile have on or not.
No. Okay. Okay. So this is the same case, right? Correct?
Yes.
So
Yes.
check this
Exactly.
case and then again give me the answer.
Okay, so Niraj, let me just say this
Start for
maybe.
sorry, yeah.
So normally when you do IPv6 pings, you have to be very specific. So you have to say maybe trace route IPv6 and
Mhm.
the address. But in this case, I don't see that. So that might be the reason why the packet is not reaching its destination.
Okay. Any other idea? Look here. In this trace, what I did, I was using a destination and a source also, but I'm getting proper reply from R2, R3, right? But then I was getting star star star. It means R4 don't know how to give reply. Till R2 till R3 everything's fine. They know how to give reply to source, how to reach destination. But R4 don't know how to give reply to the source address. Same here if I go to this diagram, right? So I can see I'm getting a proper reply from R25, but I'm not getting any reply from R22. It means R22 don't know how to reach source address, right?
Yeah.
Correct? So now we have to check two things. Let me just stop this one. Just wait. Okay. What we have to check here, R22 is not giving me any reply. It means whatever address, whatever subnet we are using in between 25 and this mobile user, that will be the source address always, correct? Because we are doing a ping from this user, right? So whenever this user will send a packet out, this at this address, the subnet address will be the source address. So R22 and these routers should know how to reach that subnet. And who is responsible for this task? R25. So we have to go to R25 and have to check R25 advertising the information to R22 or not. If advertising, then we have to go to R22, that is receiving the information or not. Okay, that is clear. Guys, if you miss anything, just tell me. I'll repeat again everything, no problem. Just tell me. This one is clear. What we are doing, why we are doing here.
Yeah, it's very clear because the packet dies on the next hop. So
Perfect.
yeah, if it dies on the next hop, you have to go to the next hop to figure out where the
I'll check
problem
on
is.
R25 that router is advertising E0/0 subnet or not. Okay.
Mm-hmm.
I'll go to R25, do show run pipe section R BGP. So I cannot, okay, I can see here we have a subnet here that is advertising. Okay, perfect. Do show IPv6 route. So whenever you want to advertise a route, just check the routing table. Okay, that will be a good method. Okay, now just tell me what we can change, or everything is fine till this point. And the interface that is facing towards this mobile, that is E0 by 0. Okay.
Mm,
Do we need any modification here?
PF just shows 2001 CC1B slash.
Okay, basically this is IPv6 ticket, right? So if you are aware like how IPv6 works and what is the subnet, the host portion, the network portion, then you'll be understand this easily. Okay, so let me explain you this one. First of all, I can see the network part, this network, and then we are having 128. So whenever we advertise a route in IPv4, if I'll use a /32, it means that route is exactly should be in the routing table and on the interface also, correct? Right? Okay. So basically what we do, whenever we advertise any network, we advertise a network, not IP address, correct? If that is on the segment. So we never advertise the IP address, we advertise the subnet. If let's say that is a loopback address, so in that case, yes, we can advertise a complete address, no problem. But if that is a subnet on the segment, so we have to advertise a subnet, right or wrong? Correct?
Yes.
That is clear to all of you, right?
Yes.
If not, just tell me, I'll explain
Yes.
again on Notepad. I hope that is clear to everyone.
Mm-hmm.
Okay. Now, the next thing, I can see here double dot and nothing and 128. It means this is indicating the full address with all zeros. But right now, we cannot send a information with 00000, right? In the source address, that will be the address of mobile user, and this is not the real mobile user, correct? That
Yes.
address is different. So what we have to do here, this is a segment address. We have to advertise a network ID, and in this routing table, we will find the network ID. Okay, so we have to check E0 by 0. So we have two interfaces. One is this one, that is C connected. One is this one, that is L. So we never choose L. What we choose C connected. Okay, so I can see here the real network ID. Okay, now we have to change the subnet from 128 to 64 because we have to advertise a network ID, not IP address here, right? So this is the issue here. I'll just modify the network ID. Okay.
Yes, could you please repeat this point?
Yeah,
Sorry
sure.
for that.
Okay. So let's say we have R1. Okay. That is connected to R2. R1 has a loopback address 1.1.1.1.1. And on this segment, we are using a subnet of 12.0.0.0 on /8. And here we have 12.1. And here we have 12.2. Okay. So whenever I will advertise this loopback address, so that is a single loopback address, that is virtual address, right? So on R1, what I can do, I can directly advertise network 1.1.1.1.1 on /32. That is fine, right? But when it comes to a segment, we cannot advertise the real IP address. We have to advertise the network address. Reason, on this segment, maybe we can have other users, right? So let's say on this segment, we have 10 users. So at that time, we have to advertise the network ID. That will carry everything, all the addresses, right? A single subnet will carry all the addresses. So in this case, we have to say network 0.0/8. This is fine. If I'll do like this, 12.0001 on /32, that will be a big mistake, right? Because in this condition, only this user will be allowed to do any communication. Let's say we have other users here, right? and this even R2 will not be able to access anything. Okay. So if that is segment, so advertise a network ID. If that is a loopback address, so easily you can advertise full address on /32. Okay. So
Understood.
this mobile user and now 25, they both are connected on a segment, so we have to advertise a network ID. That is fine, right? I think that is clear to all of you.
Yeah, it is. Yeah.
Okay, cool. Next thing we have to check, we should advertise a network ID only. So I'm just checking the configuration. Do show run pipe section BGP, router BGP, and I'll check the routing table also. Do show IPv6 route. In this configuration, I can see we are advertising a /128. It means a full address we are advertising, and this is not a loopback address. If that is a loopback address, that is fine. But right now we have to advertise a segment address. It means we have to advertise a network ID, right? Correct? Guys, yes or no?
Before.
Agree.
Yes,
Oh, yeah.
agreed.
Now we have
So
to
one is
find
supposed to, yeah,
what is
before,
the
yeah.
real network ID, and where we can find in the routing table directly we can get the real network ID. That's it, right? And what we can see here, the network is configured on /64. Just copy
Yes.
this address and advertise in the IPv6. That's it. Okay, that we have
Correct.
to. Cool. Okay.
Correct. Yeah.
So I'll just go in the address assembly IPv6. I'll say no to this information. Just say network again and advertise the said information on /64. Enter. Do WR. Okay. Now again I'll go to mobile user and we'll check the connectivity. Let me do a trace. Okay, cool. Now everything is reachable, right? So I hope this is clear to everyone. Just check the diagram. Okay. And tell me if you have any issue. Any issue if you have, just tell me. Okay, so
So what I get in this case, we have advertised the network, I mean interface IP address, right?
we were right now we have advertised a network ID, not an interface address, right?
Okay,
Because
sir.
on this segment,
Okay. This is a
on this
gateway kind of. Okay.
yes, we can say.
Okay.
Okay. For this user, this will be the gateway, but when it comes to advertise a network, we have to advertise a network ID, not IP address always.
Okay.
Okay, any other doubt? Okay, now I think we can move to the next slide, right? The next ticket. Okay. So this is done. Let me show you the ping also. This will work fine. So sometimes the ping, maybe ICMP is blocked. Okay, I'll just do a final ping to this address. That should be successful, and that is reachable. All good. So we have done the 6th ticket. Let's move to 7th. Okay. So now this is belongs to Dmvpn. So guys, I think all of you know the behavior of Dmvpn phase 1, phase 2, phase 3, and the GRE point to point, right?
Yes.
Okay. So if you know the information like the behavior, how this Dmvpn works in in the case 3, in the Dmvpn phase 3, and in this ticket, we'll be using some kind of encryption also. Okay. So first of all, I'll just read the question. So we have R15 in Uber Market headquarter that is configured as Dmvpn hub. So R15 will be acting as Dmvpn hub. it must be able to connect R18, that is POC client. Okay, fix the issue so that the users in this site can reach the VPN client, this one PC111 attached to R18. Okay, so we have to just resolve the issue, and finally we have to do these ping and trace route. Okay, so okay, so you can see R15, R17, R18, R19. So I hope everyone can see the diagram, right?
Yes,
Okay, cool.
I can see it.
Okay, so R15 will act as Dmvpn hub. R17, R18, and R19 will act as Dmvpn spoke. Okay, and we have to use here Dmvpn phase 3. In between, what connectivity we have? So I think in ticket number 3, in ticket number 2, we did these things, right? A triple P connection in between 12 and 17, and Eigrp configuration here, right? So I hope this ISP is clear, right? How R15, 17, 18, 19 will communicate to each other, that is more clear, correct, to everyone. Okay, so right now what I'll do, directly I'll go to R15. Basically, first of all, we have to resolve the issue, right? We have to check R15 should have a tunnel with R17, with R18, with R19, and over this tunnel we are using a protocol that is Eigrp. Okay, so I'll check one thing. I'll just go to R15. First of all, I will check, do we have NHRP mapping over there or not? If not, then I'll do a troubleshooting. Okay, that is clear. Guys, yes or no? I hope that is clear, right?
Yes, yes.
Okay, cool. So I'll open R15. First of all, I will check the mapping, NHRP mapping. So guys, if anyone have any doubt in the Dmvpn, so I have uploaded a video last week, I think, a Dmvpn video. So that has completed I have covered GRE point-to-point, multi-point, phase 1, phase 2, phase 3, and the working with OSPF, Eigrp, and BGP also, the RIP protocol also. So you can go through the video. Okay. Now, show IP NHRP. So I can see here only R19, right? But the type is incomplete. So we do have some issues here, right? So I'll just do one thing. I'll go to R17. We'll do a trace to the global address of this one, or we'll do a ping. Okay. Okay, before this one, I'll show you one thing. I'll go to R17 on a SPOC. Show run interface S4/0. If you remember, in triple P OE peering, we did one thing. At that time, we were doing a telnet to R17, and at that time, we did a change in ACL. Remember? So now on R17, whenever I want to pass any traffic, we have to go into this ACL and have to permit those information. Okay, that is clear. Now, do show. I'll show the tunnel configuration. Do show run interface tunnel 0. So these are the configuration, and you can see we are using a tunnel protection, that IPsec profile. Okay. So now, first of all, we have to verify and do one thing. Go to the configuration. Okay. Just shut down the tunnel. Okay. Now we have to match the configuration. Okay. So this is the IP address. Okay. No problem. NHRP authentication. So we are using authentication. The name is Ubermark. Okay. Multicast address. Okay, so IP NHRP map multicast. We have to send all the multicast address to this one, multicast packet to this address. But now, just tell me what address should be here. So guys, before starting the troubleshooting, you should know the meaning of each and every single command. Okay, why this command, why this command, why this command, why this command. Okay, and what we have to put there, the exit address. So basically, let me tell you here right now, this address should be the global address, the NBMA address of my hub. So as I can see on R15, I'll go to R15. Do show IP interface brief. So that is E0 by 0, show IP interface brief. So that has the address of .10, but I can see on R17 that is .9. So this is the first thing we have to modify. Okay, so just remove this command, modify with .10. So now we have configured whenever you want to send a multicast packet, just send it to this address. Okay, one more command we have to configure here, static mapping, IP NHRP map. What we have to map here, we are using a next hop server. Who is my next hop server? NHS next hop server 215001. So this address should be the hub address. Okay, so again I'll go to R15 and we'll check the hub address, the tunnel address. So I can see here tunnel 0 is having 215001. Perfect, that is correct. So that is fine, no problem. So let me just paste this address and this NBMA address. So we have to instruct, want to communicate to this address. What you have to do, you have to go to this address. Okay, so whenever we define next hop server, this address, we have to define this mapping. The whole time the network ID we have to mention here, otherwise it will never initiate your NHRP. So these things are explained in the previous video, in the Dmvpn video. Okay, the next hop server, the TCP, okay, and the delay we have 1000. The source should be S4 by 0. Perfect. GRE multi-point because we are using here phase 3. The key we are using, okay, this is 1 lakh. Okay, and the protection, that is IPsec profile. So now we have to do one thing. We have to verify the authentication and this tunnel key we have to verify on the hub. Okay, so I'll just go to hub on R15 and show run interface tunnel 0. So we do have here, okay, and the tunnel key is here. Perfect. I'll just verify now this IPsec profile. Show run pipe section. So let me just open. Show run pipe section crypto. Okay, so encryption AES authentication pre-share group is 14. Key is Uber market address 00 for anyone. Okay, crypto IPsec transform set, Uber ESP AES ASP. Okay, so here I can see we are using a extra authentication, that is ESP SHA. Okay, I think here we have ESP AES. Okay, cool. We are using SHA-MAC, Modi transport. Profile name is Uber Market Prof. Uber Market Prof, no problem. This is my transform set. Okay. And in the tunnel configuration, IPsec profile name is this one. All good. Okay, so I think everything's fine till this point. Okay, I'll just do one thing. I'll just say no shutdown. Go to your hub also. Interface tunnel 0, shutdown, and then say no shutdown. So you have to flag whenever we do any change in the policy in the crypto or on the tunnel. So the interface. Okay, I'll take all the questions. Just let me clear this one. Do show IP NHRP. Still we are not getting the information right. So what happens now? We have ACL. We remember that we have ACL here. Okay, so if we are using Dmvpn with crypto IPsec profile, what happens in the background? It will be sending UDP packets and ESP packets. In the phase 1, it will send UDP packets. In the phase 2, it will send ESP packets. So what we have to do here, in the ACL, we have to permit those ESP and UDP packets. Okay, so I'll go to R17. do show run pipe section no, not run, do show run interface S4/0. We have to check the ACL name, that is Uber R17. Cool. Do show run pipe section access list, so that is Uber R17. So this is okay. And what is my address? That is .22. So this is the mistake in this ACL, so just ignore that one. Okay, so UDP is allowed. The source can be any, the destination is ISACamp, non ISACamp, and destination is also okay, UDP. So this is one. Okay, everything is fine till this point. UDP is allowed and ESP is allowed to this host. Okay. Everything is fine till this point actually. I'll again back to R15. Okay, cool. We are getting a mapping and everything is fine till this point. The type is dynamic, the flag is unique register use. Okay, so what we have done here, we did a troubleshooting in between R15 and 17. Now your questions. Any question like why I removed anything, any command, why I did any modification, what is the meaning of any command? So you can ask anything. Let me show you the configuration on R17, because on R17 we did some changes. Okay, so do show run pipe section. So ask your questions.
So here in ACL, as we allowed ISAKMP, meaning we are allowing GRE port 47, right?
Okay, so basically what happens in the background whenever we use IPsec profile, if let's say we do not have this profile, so that doesn't matter what we are allowing here, right? Because then we have to allow the GRE packets, correct? But right now we are using a IPsec protection, IPsec profile for this tunnel protection. So in the background, all the packets will be encrypted, but they will send two types of packet. So we have here phase 1, phase 2. In the crypto, we have configured phase 1, phase 2. Do show run pipe section crypto. So this is our phase 1 and this is a phase 2, the transform. Okay, so using phase 1, it will encrypt the packets and will be using UDP packets. In the phase 2, it will be using ESP packets. Okay, as we are using here ESP encryption, so it will be using ESP packets. So all the packets will be encrypted in these two information, UDP packets and ESP. So what we have to modify here, we have to just modify all the ACLs if we have with permit UDP packets towards me, ESP packets towards me. That's it. Okay.
Okay.
Because globally we cannot see GRE packets because we are using a protection. So all the packets, all the ping, trace, everything will be encrypted using this profile. Okay.
Okay, got it.
Okay. Any other doubts till this point? Okay, I hope everyone is to the point. Okay. So right now, one spoke is working. So what I'll do here, I'll just check the configuration spoke to spoke. So I'll just open R18, R17 and we'll match the configuration, right? Because all the spokes will be having the same information, right? Then only they will communicate to the hub. So let's open R18. I'll just match the configuration. Okay. Okay. MTU authentication. Okay. Again, we have to modify this information. And the rest of the configuration is fine. Let me just check the profile also. Everything is fine. I'll just do a modification. Shut down the interface. No IPnHRP map 215.0.0.1. Okay, what was the command? We have to remove this command because there should be .10, no .9. This we have to modify. Okay, just do copy and paste from here. And also that ACL, maybe we can have ACL here. Okay, we do have it here. So .30 is my IP address. Okay, we have to allow ESP packets also. Okay, so just go to the ACL. Permit ESP. Source can be any. Destination should be the my interface address. Perfect. Do WR. Okay, and that's it. Just say no shutdown. Interface tunnel. No shutdown. Okay, now just go to R15 and check the NHRP table. Cool. I'm getting reply from R18 also. Now just move to R19 and check the same configuration. Okay. Everything's fine. .10, NHS is here. Let me check the crypto. Okay, group is 14, ESP is sharp, HMAC. Okay, everything is fine. Then maybe ACL issue. Right. Yeah, ESP is not allowed here. Right. So just go and permit ESP any. The destination should be my interface. That is 34. Cool. Enter. Do WR. Okay. Interface tunnel 0. Initiate your packets again. Shutdown and no shutdown. WR. Go to R15. Do show IP and HRP. Still this. Okay. Let me clear a mapping here because we already have a mapping here. So do clear IP and HRP star. Okay. Do show IP and HRP. Still we have incomplete hits R2. Okay. Maybe we are missing something on R19. Show interface tunnel 0. .19 multicast packet to this one, to this one. Okay, NHS is this one. We are missing authentication, right? So go to R18. We are missing this authentication Uber mark. Paste the authentication. Shut down. This no shutdown. Do WR. Go to R15. Yeah, cool. So everything's fine till this point. Okay, all the mappings here we have. Now, as I told you, over Dmvpn phase 3, we are using Eigrp. So now I will check, do we have Eigrp neighborship here or not, right? do show IP Eigrp neighbor. So now we have to troubleshoot with neighbor command. Now we can see those neighbors, but I can see the queue count 1, right? Queue count 1. So maybe we have some issues in the packets. I'm not able to give reply. So now I will check the configuration on R15 because I'm getting a queue count here. So I have to check the configuration here. Do show run interface tunnel 0. So, okay, right now, I don't know how to reply to multicast packets because Eigrp is a multicast protocol. If let's say we are using BGP here, no need to add any special command, but right now we are using Eigrp over this Dmvpn. So Eigrp is a multicast protocol and that user address, multicast address, right? So we have to add one special command. Anyone have any idea what command we can put here to resolve the issue? What command we can put here to indicate like you have to send the multicast packets here on these addresses? Any idea? Anyone?
The question again, please, Neeraj.
So basically what happens here, I'm getting a queue count here. Okay, and what is the issue here? The issue is like this device know how to give reply or how to send multicast packets to the neighbor. Okay, so we have to add a special command here to indicate if you want to send a multicast packet, please use these addresses. Okay, so what is that command? In BGP, that's a unicast protocol, so no need to add any special command, but this is Eigrp, so we have to add a special command to indicate what to do with the multicast packets.
This is in case of tunnel only, right? Or
yes, only tunnel, correct, because we are using a tunnel here, right? So over tunnel, it will start sending multicast packets, and but right now R15 don't know to which neighbor I have to send multicast because that is a multi-point, right? Phase 3
understood.
so we have to indicate like you have to send multicast packet here. Okay, let me, no worries. We have to say right now I'm having all the mappings in my NHRP table. So just run a command IP NHRP map multicast dynamic. What you have to do, whatever entry we have in the NHRP mapping table that is dynamically learned, just start sending multicast packet to those addresses. Okay, start sending multicast packets to those dynamic entries that we have learned in the NHRP mapping. Okay, so this user will be able to give reply. Now again we are doing a policy change, so just say shutdown and no shutdown. First I have to check the NHRP table. We should get the mapping here, then only we can work. So that will take time. Reason, these devices will send the packets after 2400 seconds, so we have to flap those interfaces. So just say shutdown and no shutdown. Okay, shutdown, no shutdown, so they will again initiate the packets. Interface tunnel 0, shutdown and no shutdown. Go to R15 NHRP. Perfect, I'm getting the mapping here. Okay, now do show IP Eigrp neighbor. Okay, cool. You can see we have these neighbors 17, 18, 19 and the queue count is 0. It means everything is fine, the neighborship is up. Cool. Now the next thing what we have to do here, just give me a minute guys. Okay, so now okay, so everything's fine. The NHRP is up, Eigrp is up. We have to just check the connectivity. Okay, so I'll just do a connectivity check from this user to this user first of all to check the end-to-end connectivity. So let me check the address here. So that has this address, so I'll just copy this address, go to this PC, I'll just do a trace. Okay, so I'm getting star. Any idea what we can do here now? Guys, again, this is a trace out issue. Okay, you have to
Yeah.
check the trace out and have to give me idea what we can do.
Yeah, so packet is dying on the next hop. That's the second trace route. So we have to find that
Okay,
device.
so this is the address of R20. This is the address of R19. Okay, and then we are getting star. So, and this is the diagram in front of you. Okay, so from this device I'm getting reply, from this device I'm getting reply, and then we are getting star, star, star. Now just tell me the issue. Just tell me the 2 point. Okay, what is the issue here?
R15 don't know how to reply the packet.
Perfect. Because we have a tunnel. We cannot say R13 is not giving me reply. We have a tunnel here, so R15 is not able to give me reply. Maybe I am not advertising the proper prefix. Okay. So I'll go to R19 first and we'll check like we are advertising the routes in Eigrp or not. Okay. That will be the very first task. Do show IP interface, sorry. Show IP Eigrp interface. So in Eigrp, we are sending E0 by 0. Okay. We have to check the subnet. Okay. So let's check show IP route Eigrp. We should get that subnet. Okay, so we are getting this 128 tool. Let me just go to R22. We'll check the subnet. E0 by 0. We have a subnet. We have to check the connected. Okay, so this is 3.128/25. Three 128/25. Perfect. Let me check the configuration of Eigrp. We are advertising everything. Let's go to our 15. Let's check what we have in this one. Let me check the interface tunnel 0 first. Okay. To show run pipe section route map that is connected. Match interface E0 by 0. Okay, that is deny. Permit everything. Cool. This is fine. And the default match IP address prefix list. Do show IP prefix list. And this one we are sending everything. A default route. Okay, cool. We don't have any issue here. Okay. Let's check Eigrp. We are sending that subnet or not. So that has a subnet of 200. So IP route Eigrp 200. I think that is this one. Okay. Now let's check the subnet on R19. So we are doing a trace to 200, 100, 200, right? And look here, we don't have that subnet here, right? So what is happening here, whenever R19 is getting the traffic, the device is checking, oh, I have a default route pointing towards 33, so I am sending the packet directly to R13, right? This is 33. We don't have that specific subnet here, correct? So this is the issue. Look here, I'll show you again. We are doing a trace to this address 200, 100, 200 or 200, okay? And on R19 routing table, we do not have that subnet, right? Can you see? We don't have that subnet here. So now we have to verify why I'm not getting that information. Okay, so maybe R15 is not sending me those information. Okay, guys, I think the issue is clear, right? The issue is right now I'm not getting any information related to this route in my routing table, and we should get that route via Eigrp, correct? Show IP Eigrp topology. Even here I'm not getting that information. So just go to R15 again and check the issue. Do show run pipe section or Eigrp. So distribute list out. We have a CPS out over the tunnel. Okay, cool. Let's check what we have in this CPS ACL. This is ACL. So in this CPS, okay, look here. In this CPS, what we have done, this is permit 000. Can you tell me what is the meaning of this 0000? Anyone? Any idea?
Permit
Default route.
Permit default route, really?
particular IP, I believe it will match particular IP.
Okay, so basically it will match a particular network that should have 0000, but right now we are not advertising any default route, correct? So what happens here, this device will just advertise a default route and will deny the rest of the information, correct? Right? So now what I'll do here, I'll just do one thing. I'll change the statement from 0000 to any. Okay, I hope this is clear, right? We are sending information out to the tunnel 0. Okay, but what we are sending only a default route, but right now we are not advertising any default route. So we have to configure here this 000 we have to change to any. It means whatever I have on my table, I can advertise to the tunnel 0. Okay, so go to your ACL, say no to permit. Okay, so just say no to 10, that's sequence number 10. Permit any, just check the ACL again. Okay, now this is permit any. Okay, we check like now we are getting the information or not, or we need to clear the process. Yeah, I'm getting the information now. Okay, go to your neighbor 112, do a trace route, and look here, the trace route is successful. So this was the issue, right? So we were expecting the issue on R15 due to not reply, but right now what happened in this situation, R13 was getting all the traffic due to the default route, right? So in this condition, what we did, we checked the routes, why R15 is not advertising the routes, right? And we found that ACL, so that ACL was allowing only a default route, not all the routes. So we just removed 0000 and had put it any, right? So using any, it will advertise everything. So now the trace route is successful. One more trace route we have to do. This was end to end. I'll just do a trace out from this PC to this PC. It means a spoke to spoke connection, right? So I'll just check the address what we have here. I'll just copy this address. That should be reachable now from this user. If that is reachable, it means everything is fine. Okay. So let's go to R19. We'll check we are getting that route or not. Okay. That is 200.100.2. I'll go to R19. Do show IP route 200.100.2. Look here, we have here 100.0, 100.3, but not 100.2, right? It means I'm not getting routes from R9, R15. I'll go to R15 and we'll check the issue. Or I can check on R18 also. So just go to R15, no problem. Do show IP route Eigrp. I'll check here first of all that I'm getting the route or not. So yes, I'm getting the route, but I'm not able to advertise to R9. Anyone tell reason behind this one? Anyone, any idea? What is the reason behind this one? Hub is getting the information from the SPOC, but is not able to advertise the SPOC to SPOC configuration. This is because of split horizon, right?
Yeah,
Whenever
yes,
I give information on my interface, I will not advertise the same information back to the same interface, correct?
Yes, that's correct. Yeah.
So interface tunnel 0. So what is the process for Eigrp? That is 200. No IP split horizon for Eigrp 200. Okay. So let's do a trace now. And that is successful. Okay. The first time, okay, now this is SPOC to SPOC directly. That was the first trace. So the first trace will go via hub and the remaining trace will go SPOC to SPOC directly. Now this ticket is done. So guys, just tell me, any doubt in this ticket? Any doubt related to this Dmvpn, IPsec, or what we did here, why we removed ACL, anything? If you have any doubt, just tell me.
I think for me, it's been a while since I revised my Dmvpn. So I think you've cleared some doubt in my mind for now. So I think I'm good.
Okay, perfect. So guys, today we have to stop here. Okay, so we have to wind up here today. So we'll continue the same session tomorrow. We'll start in morning 9 a.m. Okay, and we'll complete the remaining tickets. So the next ticket is really a big ticket. So this is our MPLS L3 VPN. So in this one, how many routers we will use? So the ticket will including R7, R8, R3, R4, 1 and 2, 5 and 6, 9 and 10, and these 6 devices. So this is the biggest ticket in this troubleshoot. Okay, so this single ticket will take around 1.5 hours or 2 hours to complete. Okay, so today we'll wind up here. Tomorrow we'll start with this ticket. First of all, we'll start on the same time, 9 a.m. IST. Okay, and first of all, we'll discuss the doubts. If you have any doubt in ticket number 1, 2, 3, 4, 5, 6, 7. Okay, so first we'll discuss the doubts. Just go through the video again. Okay, if you face any doubt, any issues, just tell me tomorrow in the session. Okay, and then we'll start this MPLS L3 VPN ticket. Okay, so any doubt till this point, guys?
Not so far.
Anyone?
I'm good. I'm good. I
All
just have to go and just revise videos again. Yeah.
Yeah, you have to revise these things. Okay, so just go through the video again and check everything. Okay.
Yeah.
Okay, guys. Bye. Take care.
Okay.
Yeah, thank you. Thank you for the session. Thank you.
Thank you. Thank you for Neeraj for your.
Thank you.
Yeah,
Thank
tell me
you.
any doubt, guys.
Neeraj, I need to revise, like go through the previous video. That's can
Yes,
I'll be able to.
that is mandate because tomorrow we'll start the MPLS L3 VPN, and that will like if you have done your MPLS, OSPF, BGP, so easily you can understand because that will be having BGP, OSPF, MPLS, VRF, everything it will be having. Okay, that's a big part.
Sure.
Okay, guys, so we'll meet tomorrow at the same time.
Have a nice day, everyone.
All right, Neeraj. Have a good
Good
one.
day,
Bye.
guys.
Yeah.
Bye.
Bye bye.
Bye.
Bye.